Okay, guys, so here you go. We'll do multiples of 5 plus we'll do problem 1 as well. So that's not a multiple of 5, but that's okay. So explain how to find the range of data set. What's an advantage of using a range as a measure of variation? What's the disadvantage? Okay, range is super easy. Just take the max minus the min, right? Minimum from the maximum. So this one is correct here, that part. Oh, actually, these are only talking about that. So minimum and max adding is wrong, adding wrong. So this is only one. Subtracting the minimum from the maximum. Okay, sweet. And what's the advantage? Only uses 2 entries, uses all entries. It's easy to compute. It is easy to compute. That's a clear advantage. And what's the disadvantage? It only uses 2 entries from the data. Does not use all, and it's not hard to compute. So yeah. Okay, that's it. Okay, in the meantime, guys, if you have any question that you remember or that you're struggling with, then always feel free to ask or put it in the chat and we can look at that one instead. Okay, this is question 5. Given the data set, how do you know whether to calculate sigma or S? Okay, so before we look at the choices, remember sigma is for a population, right? And S is for a sample. So let's see what it says. Given this, you can see a large number of entries in S. That's not necessarily true. It might have large number of entries and still be sigma. And given said data, one has to determine for representing the population or a sample. Yeah, that's right. That sounds right. So it's population then sigma, yes. And a sample then S. Let's check the other ones though, make sure there's nothing better. The data contains a large number of entries, sigma, that's not true. It's not a matter of large. You could have a very large sample and it'd still be S. So sometimes people got confused in the past where you have like a sample of say thousands of data points. Even if your sample has thousands of data points, if it's a sample of the whole, then it's still a sample. You'd still calculate S instead of sigma. Okay, letter D, when given a data set, one would have to determine if it represents the population or if it was sample. That's true. Population, then S, that's where they went wrong. So that's not the one. Okay, yeah, sigma represents population standard deviation. S represents sample standard deviation. Okay, moving on to 10. The depths in inches at which 10 artifacts are found are listed. Complete parts A through A and B. So what's the range? Okay, range. So looking for the biggest minus the smallest. Biggest looks like 43.3. Yeah. And let's see. I'm gonna open up a calculator here. So I'm gonna do my calculations on a side page. 43.3. And then the smallest looks like, where is it? 23.8. Yeah, so range you just subtract, right? 43.3 minus 23. You'll see anything bigger or smaller than that? I don't see anything else. Okay, let's check. Oh, no. Oh, yeah. 23 is the smallest. Okay, and change 43.3 to 64.4 and find the range. Okay, it's kind of silly. You just, now we have a bigger number at the top and then just subtract again. 64.4. And so now the range is 40.6. So increase the largest number. Now we have a new range. Okay, easy. All right, 15. You're applying for a job at 2 companies. Company A offers starting salaries with mu equal to 26,000, sigma 3,000. Company B offers starting salaries mu 26,000 as well, sigma 7,000. Which company are you more likely to get an offer of 32,000 or more? Okay, so 32,000, that's significantly higher than the $26,000 average, right? Both have the same average. 32,000 is outside of 2 standard deviations. It looks like if your standard deviation is 3,000, if I add that's yeah, if I add 3,000 2 times 26,000, I get 32,000, right? So if the standard deviation is 3,000, this would be at the 2 standard deviation mark away, which puts it in the unlikely area, right? It's unlikely to be that far. On the other hand, if it's only one standard deviation, if it's 7,000, 7,000 plus 26,000 is already 33,000. So that would mean this guy is within one standard deviation. So it's much more probable, right? It's much more probable. When it's outside of two standard deviations, very unlikely. If it's within one standard deviation, then much more probable. So is there a difference? Company B is more likely because data values lie within one standard deviation. Yeah. And they're not considered unusual in that case. Okay, sweet. 20. Let's see. If we're only doing multiples of 5, we might have time to do 2.3 as well, if you guys are interested. Construct a data set that has given statistics. N is 7, X bar is 22, and S is 0. Okay. What does the data value N mean? N is just the number of values in the sample, yeah. The mean there should be, this means there should be blank values in the data. Okay, that's obvious. There should be 7 values if the data sample set is 7. Okay. And what does the value X bar mean? X bar, remember, is the symbol that we use for the mean of a sample. So the mean of the sample. Okay, this means the sample mean of the 7 values should be, what should it be, guys? We want sample mean of 22, right? So the mean should be 22. Okay. What does the value S mean? S is the standard deviation, the spread of the data from the sample mean. Yeah. The spread, not the most common, not the number, not the range. This means with the sample standard deviation of 7 values, sample mean of 22 should be, you're saying sample standard deviation of 0, and already I see what's going to happen here. This is a kind of interesting question, actually. Because if I want the mean to be 22, and I want sample standard deviation of 0, that means everything is going to be 22. There's no spread, right? 0 means there's no spread in the data. Everything is right at that position. So everything is just a 22. And if everything's a 22, then you're going to get an average of 22. That's easy. If I wanted more of a spread, you could go maybe subtract 1 from here and add 1, and then you'd have still the same mean, but then you'd have a larger standard deviation. The other thing that gives it away, though, is that they're giving you most of the answers already. Actually, I feel like they didn't have to do that because we could have figured that out, right? If the S is 0, then we would have known that it's all 22s. But they put it in ascending order, and they all have only 22, so we're kind of stuck to only put 22 anyway. Okay, how are you guys doing? Is there any questions yet? Is everything making sense to you guys that we're doing so far?
Yes.
Sweet, thanks for responding. Okay, if anything, you guys write in the chat if anything's not clear. Okay, number 25. From a sample of n equal 40, the mean duration of a geyser's eruptions is 3.3 minutes, standard deviation of 0.5 minutes. Using Chebyshev. Oh, you know what? Actually, we can skip this one because we never talked about Chebyshev. Skip down. Any Chebyshev questions, we'll just skip. Amount of caffeine in a sample of 5-ounce servings of brewed coffee is shown in the histogram. Make a frequency distribution. Then use the table to estimate the sample mean and the sample standard deviation. Okay, so we gotta click on this to get the histogram picture. We're making a frequency distribution. 70.5 is the first midpoint, and it looks like the frequency is 2. And this XF is just the product, because what they're getting at is this is same idea as making a weighted mean. It's kind of how you do it. You take the frequency, multiply them by, if you don't have a single data value, what you do is you just take the average of that range. And that will give you a sort of weighted mean. So you just multiply it. XF is 70.5 times 2. 5.5 times 2, which is 141. And then looking at it, next midpoint is 92.5 with a frequency of 12. And the rest is kind of the same thing. So that'll be 12 times 92.5. And that gives us 1,110. Oh, wait. Yeah, that's right. That's right. 1,110. It sounded like a lot at first, but then yeah, that's actually great because this is 12. Okay, next midpoint is 114.5 with a frequency of 24 now. 24. So this will be our largest one. 24 times 114.5 is 2,748. Next is 136.5 with a frequency of 8. 8 times 136.5. That's 1,092. And then last one. Frequency is 4. 158.5 with frequency of 4. And that's a 634. Okay, so now we see the sum of, do you remember this capital sigma means to add it up. So this is going to tell us the total frequency, or in other words, our sample size. So we're going to add 2 plus 12 plus 24 plus 8 plus 4, and that's going to give us 50. There's 50 values in our sample. And then this is the sum of these xf's. That means just the sum of these multiplied values. Yeah. So the sum of basically what that gives you is it gives you kind of like the sum of all the data values in a way, except we don't know the individual specific data values. So since we don't know the individual data value, we just take the average of the class as being the value that we choose. So this in case it would be 141 plus 1110 plus 2748 plus 1082 plus 634. Okay, so just to reiterate what this summation does. So let me write the number first. That's 5,725. That would be like, so let's say I don't know what my data points are, but I know what classes they're in. So if I look at that first class, it's somewhere between I don't know where this is, but like is that 60 something, and I don't know wherever that is. 70.5 is in the middle, right? So I don't know what values are actually, but I know they're in this range. I'm just gonna call them both 70.5. So when I add up all my values, this is like I counted 70.5 twice. I counted 92.5 12 times, 114.5 24 times, 136.5 8 times, and 158.5 4 times. And I add up all those numbers, and this is what I would get. So now to find the average, then this is the total, right? Total of all my data values. I kind of simplified it by calling them whatever the midpoint was. And then I just divide by how many there are. So I take that 5725 value and divide it by 50. That will give me my average of 114.5. 114.5. Okay. And then before we continue the next part, let me show you one more thing. So we in our class, to do the weighted mean, I've been telling you guys to use the Google Sheet. So let me show you how that would look in this particular case. Let's see. How am I gonna do this? Gotta change the sharing. Just give me a minute here. Okay, so here's my Google Sheet. And for the values, what I would choose is those midpoints. Oops. It's kind of backwards from the what they had told me in order, I mean, because they listed their frequencies first. 70.5 was the first midpoint, 92.5, 114.5, 136.5, and 158.5. Okay, and then we're gonna repeat those frequencies. It was 2, 12, 24, 8. And last one was 4. Okay, so when I do that, look what happens. The weighted mean, this is your X bar, yeah, 114.5. And that agrees with what we just calculated down here, yeah, 114.5. Okay, now to complete the table, round the values to the nearest tenth. Okay, so this is the X minus X bar. That would be the 70.5 minus this 114.5 there. So I'm going to do that side on the side. 8.5 minus 114.5. And this question is taking a while, so it looks like we might just we might not get to 2.3 at this rate. But then again, we only have like two more questions after this. Okay, so that's negative 44. And then when I take that difference and I square it, what do I get? So it looks like to me what they're getting at is they're sort of building towards the standard deviation 1936, which is not something I normally ask guys to calculate. So this is the difference. This is the difference squared. And then I take that difference squared multiplied by the frequency. In this case, the frequency was up here, it was 2. So multiply that 1936 by 2. And I get 3872. Let's check. Okay, sweet. And then we just repeat that over and over. So this would be 92.5 minus 114.5. And I got an idea. Okay, here's my idea. I'm gonna do this in Desmos. Hold on, let me actually set this up for a moment. Okay, so what I'm gonna do just to make my life slightly easier is I'm gonna just input that difference here. Here's the one I'm checking, 92.5 minus the mean, 114.5. And then in the next line, I'm just gonna take the answer. So right, A and S, and then square it. So that'll be the squared version. And then in the next line, I'm gonna put answer from that, and then multiply by whatever the frequency is. In this case, the frequency was, what was it? 12. So here's my three answers: negative 22, 484, and 5808. And then the next one, I'm just gonna replace this number 92.5 and replace this frequency, and then I get my new answers. All right. Let's see. Okay, this is kind of, you know what I should actually do? I should do this in two side-by-side windows. Okay, so I'm gonna change views here, guys, to make it easier for us all. Okay, let's do a new share. Let's see. Are you guys seeing my whole desktop now? You guys see it together, both screens?
Yes.
Okay, sweet. Thank you. Okay, so here it is, negative 22. And this one was, I gotta move this one over a little bit. Negative 22, this one is 484, and this one is 5808. Okay, next one is 114.5. And that makes everything 0 automatically, no matter what the frequency was. So just so happens that the mean is exactly 114.5, which I don't know if that just so happens or they purposely did that. Okay, next value is 136.5. So change this to 136.5. And I get a positive 22 this time. Interesting. Square version is still going to be 484, just like when negative 22 is squared. And this time the frequency, though, is 8. So change this here to an 8. 5872. Okay, 158.5 5 is the last one, so it changes to 158.5. And oh yeah, so that must have been purposeful. 44 is the gap now. When I square it, I get again 1936, but the frequency was 4 this time. So the 4 is going to give me a 7744. Okay, and then now add all these guys up together. And yeah, for sure they're building towards the standard deviation here. So that's 3872 plus 5808 plus 0 plus, and while I'm doing this, hope you guys appreciate that you don't have to do this normally. Because what we're doing right now is we're calculating the standard deviation, and you see that it's a long, tedious process. And we just are avoiding that. Okay, remember in the formula for standard deviation, it is exactly pretty much this. You sum all the differences from the mean squared times the frequencies. And in the end, you divide by the sample size minus 1. Oh, actually, no, I'm missing a couple steps. This is actually the variance is this divided by s minus 1. That'll be 21296 divided by our sample size was 50, remember? So it should be divided by 49. That's the variance, but then I want the square root of that answer to give me a standard deviation. And before I enter, I'm going to double check my work by, so here's what I think it is, 20.85. Let's double check my work by just checking back at our cheat sheet, our Google sheet here. And look, if you look at our Google sheet, we have our values entered, right? Remember how the weighted mean automatically calculated? Look here, sample standard deviation, 20.85 to the nearest 2 decimal places. And that's the same number we had over here. So, oh, sweet. We did it correctly, that means, and everything should check out. Let's double check. Good job. All right. And we feel so accomplished. Now there's 2 more questions. Let's see. Let's take a peek. If it's another long one like that, I'm not going to do it. We'll do something different. Okay, use SS sub X. Okay, this is not something that we talked about. So again, I'm not going to go into this, but again, it looks like this is just talking about how to calculate the standard deviation again, variance and standard deviation, alternative formula, convenient, but we don't really need to worry about that because we just use our cheat sheet. So skip down. Okay. Oh yeah, this one might be interesting. At least 96% of the data in any data set lies within how many standard deviations of the mean? And we're thinking we're using the empirical rule. Explain how the number of standard deviations could be found for any data set. Actually, I'm not sure we learned the more powerful versions yet. Yeah, this is another Chebyshev theorem. So we didn't learn Chebyshev's theorem. Okay, so that's actually another skip. Because the empirical rule is only for very specific standard deviation, at single standard deviations, yeah. In a later section, what we will learn to do is we'll learn to handle those values that are not exactly at 1 standard deviation, but that's not till, I think, chapter 5, I want to say. So yeah, that's a little bit later. Okay, so that means we're done with 2.4 for now. Any questions, anything you guys see?
I don't have a question on this, but I have a question relating to Math 78.
Okay.
So I don't know if you want to continue with
Yeah,
this.
let me stop this recording first.